All right, so for my second video, first off, you had to see the first video to see how this worked, to see how we got to this equation. But for my second video, I want to answer what this has to do with a 6-year-old or a 7-year-old or 8-year-old. I don't know what the age they teach it in elementary, exactly what the recommended age is. I know that I often get tests of teaching 6-year-olds who are way ahead in math, and I just have to teach them something, and this is easily accessible for me, and they love it, and they actually get it. So again, I'm just putting that disclaimer out there. I don't know exactly when to teach this. I don't know what the official time is. I'm just saying a lot of my students, when they're old enough, they get it. People ask about, like, yeah, but you're not taking that and putting numbers in and doing the equations. No, we're not. That's not the whole point of this. The whole point is to get them to understand these mathematical ideas so that once they do get to the point where they can start putting numbers in here, they understand the meaning. They know that a squared, 1a cubed, whatever number this is, if it's 9, it's going to be 9 3 times. So it's going to be 9 times 9 times 9, which is, I should know this off the top of my head, 729. So I had to look actually at the chains, and then I remembered it's 729. So they'll remember that. If this is 9 and this is 5, then 9 times 9 times 5, which is 9 times 9 is 81, times 5 is 405. Like, you're getting the picture of where I'm going with this. They have a better understanding of what this means than somebody who just worked on it on paper. A lot of times, people I run into don't understand math because they only did it on paper. They didn't work with these. This also comes after them handling this material so much and lining it up and being able to picture exactly how to line it up. Like, literally every time I write down these equations just by hand, I'm picturing the different pieces. Just how it works. I wouldn't do this necessarily the first lesson. I would say, okay, if it's like this, that's a square, and this little number, you don't even have to use you could tell them it's called an exponent. You don't have to. But that little number is 2. Actually, you might even, I haven't done this yet, but I'm like, if it's just a line, not a square, that's 1. If it's a square, that's not little numbers. It's going to be, for square, is going to be 2. If it's a cube, then, and they're all the same, that little number is going to be 3. I wouldn't do that right away. That's something you can do later. But what you're doing is giving them the actual image of this equation and how it fits together in their head, so they can actually think. They don't have to memorize this. They can think about it, and it's there. And so when it does come time to add numbers in there, then they're already set. So yeah, that's my second commentary on this. Again, I'll do the trinomial one eventually, but I'm wondering if you've never seen this. If you have the trinomial cube, try it out. Let me know what you came up with. Be interesting to see if you can apply, try this out. If you get good at this, go to the trinomial cube, the one with the yellow on it also, and see how well you can do this. See if you can get the trinomial cube equation. I will post a video on it. I wonder if you can get it.